Hi everyone, welcome to Medicine Note YouTube channel. In this video we are going to see about vitamin B12. We have already discussed a video in vitamin C. Now in this video we will see about the vitamin B12. The other name is anti-pernicious anemia vitamin, synthesized by only in microorganism. It is otherwise known as anti-pernicious anemia vitamin, synthesized only in microorganism. Now we will see about the chemistry. The structure of vitamin B12 consists of coring ring with central cobalt atom. This cobalt atom has a valency number of 6 and the sixth group contains different following groups. Example, cyanide, which forms cyanocobalamin, adenosyl, which forms ADO-B12, hydroxyl, which forms hydroxyl cobalamin, which is used in injectable forms, and methyl forms methyl cobalamin, which is the major form in blood. Chemistry is, it is a structure of vitamin B12 consists of corin ring with central cobalt atom. There is a ring, in centrally there is a cobalt atom. The sixth valency of the cobalt contains any one of the following group. The cobalt sixth valency contains any following group, which is cyanide, adenosyl, hydroxyl and methyl. These are the group which forms the cyanocobalamin, ADO-B12, hydroxycobalamin, which is used in injectable forms, and methylcobalamin, which is the major form in blood. The important coenzymes are ADO-B12 and methyl B12 are the functional coenzymes of the B12. Absorption. Absorption of vitamin B12 requires two binding proteins. When the vitamin B12 is want to be absorbed, it requires two binding protein. They are intrinsic factor and cobalamin. The intrinsic factor is secreted by gastric parietal cell and it is a glycoprotein. Now we will see about the intrinsic factor, which is secreted by the gastric parietal cell and it is a glycoprotein. One molecule of the intrinsic factor combined with two molecules of B12. When the intrinsic molecules are there, it combines with the two molecule of B12, and this IF, intrinsic factor, as well as B12 complex is attached to the specific receptor on mucosal cells. The complex which is formed by the intrinsic factor and the B12, two molecules of B12 are attached in the mucosal cells, and the B12 is absorbed from the ileum. And this complex is internalized. This is how the absorption takes place. First, the intrinsic factors is secreted by the gastric and parietal cells and it is a glycoprotein. Now, one molecule of this intrinsic factor combines with the two molecules of the vitamin B12 molecule, and this intrinsic factor and the B12 molecule complex are attached in the specific mucosal cells, and these mucosal cells are internalized and the B12 is absorbed from the ileum. Now we will see the biochemical function of the vitamin B12. Synthesis of methionine from homocysteine. There is synthesis of the methionine from this homocysteine. Homocysteine with N-methyl THF, which is tetrahydrofolate, as well as the THF is gone away, and with the help of vitamin B12 it forms methionine. And methylmalonyl CoA to succinyl CoA. Methylmalonyl CoA to succinyl CoA. The propanonyl CoA, the amino acid, and thiamyl uracil. These three leads to the formation, results in the end of methylmalonyl CoA. This methylmalonyl CoA, the help of vitamin B12 and the enzyme which is mutase, is changed into succinyl CoA. This is the second function of the vitamin B12. If the deficiency of the methylmalonyl CoA accumulates, when there is deficiency of vitamin B12, the methylmalonyl CoA accumulates, because the methylmalonyl CoA is changed into succinyl CoA by the help of the vitamin B12. When there is deficiency in this vitamin B12, the methylmalonyl CoA accumulates and excreted in urine as methylmalonic acid. The sources of the vitamin B12 are: vitamin B12 are generally synthesized by only microorganisms. Curd is the better source of the vitamin B12. Now we will see the RDA. For adult, which is 3 mg per day, as well as for pregnancy it is 4 mg per day. Now we will see about the deficiency manifestation. Folate trap. The vitamin B12 deficiency causes folate deficiency, and also it is due to folate trap. The megaloblastic anemia. In peripheral blood, there is megaloblast and immature RBCs are seen. The megaloblast anemia means the RBCs are very big in size and they are immature. So, in peripheral blood, there is megaloblast and immature RBCs are seen. The abnormal homocysteine level. The homocysteine converts into methionine with the help of vitamin B12. So, when there is deficiency of the vitamin B12, the homocysteine level increases. In B12 deficiency, homocysteine is accumulated and lead to homocysteinuria. Demyelination. Accumulation of methylmalonyl-CoA interferes in the myelin sheath formation. Generally, the methylmalonyl-CoA is changed into succinyl-CoA with the help of vitamin B12. Here, due to the deficiency of the vitamin B12, the methylmalonyl-CoA is accumulated more, so this interferes myelin sheath formation. Thank you. If you like this video, please do like, share and comment my YouTube channel. If you want any other topic, please do suggest. If you have any doubt in this video, comment in the comment box. Thank you. Please do subscribe.